So in the previous lesson, we learned how to change the coefficient right here, that coefficient right there, to change the number of mole of a specific element in a substance. But it's also changed the total number of moles of the whole entire substance, because now you're having more or less, right? So basically, if you change the coefficient, you change the total number of moles for each of the element in the substance. Now we are going to look at balancing chemical equation. Now, just a review, we basically look at the term chemical equation when we have when we take reactants and we combine them together and they make product. So in this process, we're making from one substance changing to a new substance. Before that, we need to realize there is a law of conservation of mass. Think of the term conservation. That tells you it is fixed or conserved. So the law of conservation of mass states that matter is neither, that means not, created nor destroyed. So you don't create new matter or you destroy the matter when there is a chemical reaction. What does that mean? That tells you that whatever the amount of mass you put in on the reactant side, that will equal to the amount of mass on the product side. And because the mass stays the same, the number of moles must also stay the same as well. So because the number of moles stay the same, as well as the number of atoms or molecules stay the same. So that is the beauty behind the law of conservation of mass. That will tell you the mass, the moles, and the atoms of the reactant must equal to the same thing as the mass of the product. So the law of conservation tells you that the number of mass, moles, or atoms of the reactant size must be equal to the mass, moles, or atom of the product side. Now in this lesson, we are going to focus on how to balance the chemical equation to prove that the law of conservation of matter exists, or mass exists. Well, there is only one rule when it comes to balance chemical equation. And the only rule is that you can only change the coefficient number. And we learned that changing the coefficient number increases or decreases the number of moles, right? But here are a few tricks. The first trick is that always balance the metal first. Then you can balance the other non-metals. And if you see a polyatomic ions, balance the ions as a unit. So for instance, we have CO3 2 minus on the reactant side, okay? And then on the product side, you also have CO3 2 minus. If there are two right here, of course over here, we don't just look at carbon and oxygen individually, but if there are two of that right there, of course I know there are going to be two of that right there. Notice how it is a unit rather than by carbon and oxygen separately. And then we have the last part, is always balance the hydrogen and oxygen last. Okay, always balance them last. Okay, why is that? Because usually they exist as elemental elements. What does that mean, elemental element? For instance, we have H2O2. So because of the term elementals, what about when we have calcium or any metal like barium by itself? We will save them last as well, even though it's a balanced metal first. Whenever we have the elementals, always save the elemental last. Here's the most advanced part of all, is that sometimes we can use fraction and we can multiply the entire fraction by the denominator to remove that denominator if necessary. So we save this later, okay? This is more advanced steps. So let's see how easy it is to balance a chemical equation. Let's look at this one. We have N2H2 and that produces NH3. Again, balance the metal first. We don't have any metal, so the next thing is balance the non-metal. So again, the only thing that you can do is change the coefficient. And let's go back and apply our little hints right here. Since we don't have any metal, so we can start with our non-metal. And of course we save the hydrogen last, okay? So here we have 2 nitrogen, and here I have 1 nitrogen. The important thing is that this is 1 right there, that's substrate right there. So what does that tell you that we need to put here? So in order to get 2 nitrogen, we need to put the coefficient of 2. Now we have 2 nitrogen, isn't that great? But that also changed the number of hydrogen, because 2 of 3 of hydrogen, that gives us the total of 6 hydrogen. Okay? Now, the nitrogen is balanced, but the hydrogen is not. So we save that last, which makes sense. Here's what the tricky part. We can actually use fraction. Okay? So notice how we have a 2 right here, right? And we have 6 right there. We can make that into a fraction. 6 over 2. And we can simplify that into a 3. And the answer is 3 right there. But we can actually think this in terms of common sense wise. If I have 6 hydrogen here, right? And each of H2 give me 2, how many more, or what is the coefficient here has to be to give me 6 hydrogen? Of course, it's going to be 3, because 3 times 2 give you 6. So here we have a mathematical way of thinking about that. So we have 6 hydrogen, but we have 2 right there, right? So 2 times x, what is that x going to be? Of course, it's going to be 3. So there are multiple ways to solve this problem. And of course, this one will be just 1 by itself. So again, there are many ways to solve for the coefficient. Let's try another problem. Again, we save oxygen last, right? Here we have 2 nitrogen, then we have 2 nitrogen. Oh, it's balanced already. But look at the oxygen. We have 5 here, so we have 5 O, but we have 2 O right there. We can use a fraction, okay? So these are oxygen, not just 50, okay? So in this case, we can use a fraction, 5 over 2, okay? Product over reactant, or whatever you think that case is. So how do I get rid of that 2? Just like in math, you multiply everything by the denominator. So of course, that 2 cancel out because it's simplified to 1. And 2 times blank, which is supposed to be 1, give us 2. And now that's 5 right there, right? And 2 times blank give us 2. And that is our answer. 2, 5, 2. Now does that work? Let's check. We have 4 nitrogen and how many oxygen? 10 oxygen. And here we have 4 nitrogen and it is 10 oxygen. Isn't that easy? So that's the beauty of using the event technique fraction. Now if you don't like to use the term fraction, you can think of common multiples. Notice how we have 2 oxygen and 5 right there, right? What is the common multiple? Of course the common multiple is 10. So from 5 to get to 10, we'll multiply by 2, which give us that, okay? And then from 2 to give us 10, that will multiply by 5, which give us that. But once you put a 2 here, that would affect the number of nitrogen, right? So 2 times 2 give us 4 nitrogen, and what we have here, we need to put a 2 there. So that's another way of thinking about this problem. Let's try another problem. Here we have this chemical reaction, right? Zinc. Let's try another problem. Here we have this chemical reaction. Oh, look, zinc is a metal, but it's already balanced, right? Oh, isn't that easy? And then we have sulfur, okay? It has 8 sulfur here. So what is this coefficient has to be? Of course, it's 8. 8 times 1 gives us 8. But that's going to change the number of zinc as well. So in this case, this one has 8Zn. So what this has to be? So what is the coefficient it has to be? Of course, it's going to be 8. Now everything is balanced. So we have 8Zn, 8 sulfur. Same thing in this case, 8Zn and 8 sulfur. Isn't that easy? Ready to try another problem? Whew. Now let's try another problem. Here we have this chemical reaction again. Look, aluminum is a metal, so here we have 2 aluminum, right? But in this case, this aluminum is elemental form, so it doesn't really matter. It's so easy. So what we have here is this. We have 2 here, so we need to put a 2 there. Now we have 2 aluminum. Okay, aluminum is balanced. So what do I need to do? Then I have sulfur right here, where in this case I have 3 sulfur and this one I have 8. We can use the fraction method. Now let's try the fraction method. Again, always relative to whatever you put a fraction at. In this case, you put a fraction over here. This will be on the bottom, so 8 and then 3. How do I get rid of that 8? Of course, I have to multiply everything by 8. That gives me 16. That cancel out, okay? And this blank, so that gives us 8. Let's check if this actually works. So aluminum, we have 16. Sulfur, So far, how much do we have? Well, 3 times 8, that gives us 24. And over here, we have aluminum. What is it? 8 times 2 gives us 16. And 8 times 3 gives us 24. Isn't that easy? So easy. Beautiful. Now, let's try 2 of the hardest problems that you will see. Okay, are you ready? And here's the reason why it is challenging. Well, first, we realize that the metal is already balanced. Okay, easy. Then we go to hydrogen and oxygen. So which one do we do next? Notice how I use the term elemental form, right? And I circled that. That is more important than just hydrogen and oxygen. So we have oxygen and hydrogen. And of course, hydrogen we will do last because it is an elemental form. So here we have one oxygen and one oxygen. Oh my god, it's balanced too. Let's go to the next one. We have hydrogen here and hydrogen there. That's what makes it all so complicated, because we have hydrogen in 2 different places. And look at the number. We have 2 here and 1 there. That gives us a total of 3 hydrogen, right? And on this side, guess what we have? We have 2 hydrogen. Now we have an even number and an odd number. That even make it more challenging. But we realize that when it comes to multiplying, it's easy to have an even number. So how can I make that an even number? Well, what's the next even number after 3? Of course, it's 4. And if I increase this right here, that's not going to give an even number because continue to add 1 on this side. So I had to make this odd number over here, 1 hydrogen, into 2. And what do I need to do for the coefficient? Of course, I put a 2 there. Now I'm going to have 2 hydrogen right there, right? And that gives us a total of how many? Of course, 2 plus 2 gives us 4 hydrogen. Beautiful. Now we can work with this even number. So if I have 4 hydrogen over here, and each one give me 2, what does that coefficient has to be? Of course, it's going to be 2. 2 times 2 give me 4. But that's going to affect the number of oxygen as well. 2 times 1 give us now 2 oxygen. Whoa, okay. Let's go back. So now the hydrogen is balanced. We can give that self a check, right? What about the oxygen? Here I have 2 oxygen. And I have 2 oxygen. Oh, look, 2 times 1. Oh, the oxygen is balanced. Now what do we have? Potassium, okay. We have 2 potassium here. And we have 1 potassium. Oh, look, potassium is the elemental. It's just by itself, so I can just put a 2 there because it doesn't affect anything else. And we're done. Look at that. K is now balanced. So now do you understand why this has become more challenging because of that hydrogen in 2 different places? Not only that, the total gives us an odd number. So the key is that we have to make it so that's even first. And of course, there's a 1 right there. Now let's try another problem. Here we have, of course, the calcium is already balanced, okay? The oxygen is balanced, and yes, it's balanced. Ooh, oxygen is not balanced. We have 2 of oxygen there, okay? But we have oxygen and hydrogen. Which one do we do next? Of course, oxygen, because we have an elemental hydrogen here. So I have 2 oxygen. Of course, we need what right there? 1 times what will give us 2? The answer is 2. Now that's going to affect the number of hydrogen, is it? That gave us 4 hydrogen. Do we have 4 hydrogen in this case? Here, over here, we have 4 hydrogen. What about here? We have 2. That gives us 2 hydrogen. Okay. And what about right here? That gives us another 2 hydrogen. Oh, 4 hydrogen. Okay. So the hydrogen is balanced. What about the oxygen? 2 oxygen and 2 oxygen. Oh, it's balanced. And what about the calcium? Oh, 1 calcium and 1 calcium. There you go. Oh, look at that. So easy. And we are done. So that is how you balance chemical equation. Always apply this strategy and use the hints. Always use this. Change the coefficient only and use this hints in order. Balance the metal first, followed by the non-metal. And balance polyatomic as a unit. And then balance hydrogen and oxygen, especially elementals 1, last. Then use the fraction, always relative to where you put the fraction. That's how we know it's on the bottom. Like right here, I put the fraction on this side, so that's why this is on the bottom. If I put it on the other side, it would be the opposite. Okay, so keep that in mind.